By now, we learned a lot about keeping our list of function parameters short and concise and keeping the function body short and concise. Now, there is another aspect of writing clean functions which you should keep in mind. And that is that you should try to keep your functions pure. Now, what does this mean though? What is a pure function? A pure function is simply a function which, for the same inputs, generates the same output. So for the same input parameter values, you always get back the same output. And this here would be a simple example, this generateID function. It takes a username as a parameter, it then combines that with a hard-coded string, and then it returns this ID string which was generated. Now, as you can see, if you have a look at this code, for the same username value, like max, we will always get back exactly the same return value. This is a function which is 100% predictable and which therefore is pure. Now here's the same function again, now however defined as an impure function. This function, unlike the first one, does not always yield the same result for the same input because we do generate a random number which we convert to a string which we then combine with the entered input value. So for the same input value, we will always get a different output value here. Hence, this function is not pure. Now, it's not necessarily bad to have impure functions in your code and in your program, because sometimes you just need something like this. Sometimes you might need to generate a random ID and return that. So it's not the case that impure functions are always bad, but they are definitely less predictable than pure functions, and hence you should only go for impure functions if you really need that behavior. And that's especially true if we don't just consider the generation of a random value as part of your function, but if we specifically have a look at another concept, side effects. Pure functions shouldn't have side effects, which again does not mean that you are not allowed to have side effects at all, but a pure function wouldn't have a side effect, and therefore you might want to minimize the number of functions that do have side effects. Especially when following a functional programming approach. If you're really trying to strictly follow such an approach, it is quite common and expected that the vast majority of your functions, which you compose and combine together, are side effect free and pure. And then you would only have a couple of places in your code where you do have side effects. Now, of course, you don't have to follow the functional programming approach. You could have an object-oriented approach or kind of a mixed approach, an imperative way of writing code, and therefore you don't always have to be that strict. But in general, as you will also see over the next minutes, side effects are definitely something you should be aware of when you write clean code. But for that, let's first of all clarify what actually is a side effect. Well, here's a simple example snippet. This createUser function does what the name implies. It creates a user by instantiating a user object by using the constructor, and then it returns the user. So like this, it would be a pure function. It will always give us the same kind of user object whenever we run this function. However, let's now say we have this line of code in the function as well. This start session line of code. Now, this function, which we call here, is very likely to change the overall state of our program. And that's what we call a side effect. It's an operation which does not just act on the function inputs and change the function output, but which instead changes the overall system or program state. For example, start session could change some variable outside of this createUser function. And when you have such a side effect, a function is also not considered to be pure, because even if it does always return the same value for the same input, if it does something else in addition to the work it does on the inputs, then it's also not considered to be pure. So a pure function is only pure if it always gives us the same output for the same input and it doesn't have any side effects. But what's the problem with such side effects? Again, you won't be able to always avoid them. Indeed, depending on the kind of program you're writing, you might need a lot of side effects, because there are a lot of potential side effects. Starting sessions, sending HTTP requests, even logging something to the console or showing some message to the user would all be a side effect, because it's a change to the state of your system and of your program, right? I mean, if you show something to the user, that's definitely a different state your program is in than a second ago when you didn't show a message. So these changes are everywhere, and side effects are everywhere. But side effects do become a problem if they are unexpected. They're not automatically bad, we need them. But if your side effect is unexpected, then it is a problem. For example, in this createUser function, you could kind of expect a side effect. Maybe createUser implies that the user is also stored in a database, and that would also be a side effect. Starting a session could also be a kind of expected side effect. So in this example, it might not be a bad side effect at all. But consider this example here. It's again the generateID function, but now it's not just generating and returning an ID, it's also assigning that generated ID to some global state, to some global variable which we have in this program. This is a side effect, because it's not just work we do on the input and output of this function, it is work we do on some other variable in our program. Now maybe we need to keep track of that last assigned ID. Maybe that is some internal work we do, but maybe it's also not something we expect when we call a function named generateID. Maybe a simple change in the name to generate unused ID would suffice here though to make it clear that this function will need to check whether an ID has been used or not, and that therefore it might also interact with the global system state. So that could be one possible fix here, instead of just keeping the name generateID like this. Because that is the strategy for avoiding unexpected side effects. As I said, and I really want to emphasize this, side effects are not necessarily bad, but your naming matters. Side effects do become bad if they are unexpected. And therefore the name of a function should signal or imply that a side effect is likely to occur. Otherwise, it's considered a bad side effect and therefore not clean code, because clean code doesn't do unexpected stuff. Clean code is, well, clean, easy to read and easy to understand. And if something happens which you didn't expect, you clearly did not understand the code, hence the code wasn't clean. So have a look at these example names here, for example. If you see functions named like this, where would you expect a side effect? In SaveUser, we do expect one, I would argue, because SaveUser implies that this user is probably going to get saved to a database, and saving data to a database definitely is a side effect because it does manipulate the overall system and program state. After all, we write a new entry to a database, we change files. This is a crystal clear side effect. And we do expect such a side effect for a function named SaveUser. On the other hand, if we had a function named isValid, then we do not expect any side effects there. We do expect that this function maybe answers the question whether some input or some email address is valid. It would be very much unexpected that this function then sends a message, writes to the file system, shows a message to the user, or changes any other program state. Now what about showMessage? showMessage, per definition, will have a side effect. If we show a message to the user, no matter if that's the terminal or console, or if that is an overlay on a website, if we show a message to the user, we are definitely changing the program state. because the state will be a different one if we have an overlay on the page than it was a second ago when the overlay was not there. So here, because of that name, a side effect would be expected. Now, what about create user? Here, I would say you could go either way. You could say that you don't expect a side effect because a function named create user will probably do just that, create a new user. On the other hand, create is a very wide word with a lot of interpretation you can put into it. Create could mean that saving that user to the database is part of the creation process, or that validation of the inputs and showing an error message is part of the creation process. So here, it really comes down to the overall context of the application in which you use this function. A side effect is not necessarily expected, I would say, but it's also not totally unexpected. And over the last lectures, we indeed had a function named createUser, which did have various side effects. And therefore, long story short, the idea is simple. It is okay to have impure functions, and it is okay to have side effects. But whenever a function is impure, typically because it does have a side effect, that should at least be expected. Your functions should not have unexpected side effects. And if you have a side effect, or if you need a side effect, you should therefore either choose a function name which implies that, then it's absolutely fine, or you should move that side effect operation into a different function where it again is expected. This is important to ensure that you have clean code and clean functions, because it's definitely not clean code if your functions do something which is not expected. Now we learned about side effects and pure functions. Let's now have a look at a couple of examples here so that you really get a feeling for what a side effect is and how you could mitigate it. So here's a code file, which you, as always, find attached. And this code file contains 3 example functions. Now, as so many code files, you won't be able to really execute this file. It's not doing anything. It just has a couple of example code snippets. And now I want you to pause the video and have a look at these different examples here. And then try to identify all the side effects you can find. Just add a comment next to them or write them down on a piece of paper. And also think whether that side effect is expected or not. And if it's not expected, how you could potentially avoid it and work around it or make it expected. So take that chance to pause the video and do that. Thereafter, we'll walk through that together. Were you successful? Let's take a look. And let's start with connect database. If we call a function named connect database, we do expect that a database connection is established. This, of course, would be a side effect. It changes the overall system and program state. It's an important difference whether our program is connected to a database or not, after all. So therefore, we would expect a side effect in such a function, and indeed, we do have one. Actually, we have 2, but let's start with the first one. This is the first one. Calling database connect is probably the code that would really establish a connection to some database. So this is the code which ultimately will change something in our system, and therefore this operation will definitely be a side effect. And again, it's not an unexpected side effect at all, so there's nothing wrong with calling this function here. However, we do have a second side effect here. Did you spot that side effect? Well, in the end, it's this console log statement down there, where we output whether we were able to connect or not. Now, this is also a side effect because showing a message to the user is a change to the system state. Now the question is whether it's okay to have this code here or not. And you can definitely discuss this. We do have a name, connect database, which implies that a side effect will happen. But it's this first side effect which we expected, not necessarily the second one. But that is now exactly the thing we could discuss. Because you could also make the argument that a function named connect database indeed might also take care about the error handling if that connection failed. So you could argue that it's not unexpected that we don't just connect to the database, but that we also show an error message if that connection fails. Because connecting to a database does not just include the success case, but also the failure case. That is an argument you could definitely make, and then having this other side effect would not be unexpected. You could, however, also argue that the only thing which is expected is indeed that the database connection is established, and nothing else. If that's the case, you could solve this problem by simply creating a new function, which you could call initApp, so a function which is called at the beginning to initialize your app, and in there you call connectDatabase, and you expect to get back a success value, let's say, and then you grab your console log message here, and you check if it's not a success here, in which case your initialization ends and you just show this error message, and otherwise you continue with other initialization steps which you might have. And in connectDatabase, we therefore just return did connect, which could be a true-false value, originally returned by connect, which then is in the end checked here. This is something you could do. Now you could argue whether we really need a separate connectDatabase function then, since that's in the end just renaming the operation we're doing in there. But it could be the case that we are doing more. For example, we could be preparing the connection URI, and we could be doing work here. So ultimately, if we do more work, having this separate function could make sense. If we really just call database connect, then indeed we just rephrased the operation, and hence extracting this extra function might actually not be a good idea. And we should have went with the initApp function right from the start. And I'm just discussing all these different options to also make it clear that clean code always is something which depends on personal preferences and the general context, and it's something you can argue about. And that is important. There is no single right or wrong solution. But my goal with this course is to show you many potential factors which you should take into consideration and many potential strategies you can use to derive and write cleaner code. And therefore this here is now my solution for this first example. As you can tell by the discussion we had here, definitely not the only solution, but now a solution where I would argue that all the side effects are not unexpected and where therefore we did write some clean code. So let's now move on to the next function, determine support agent. Here we're getting a ticket, and then in the end we check the request type, which seems to be stored in the ticket, to either find a standard agent or an agent by request type. And then we return this agent. Now, does this function have any side effects? Well, it most likely does not. Maybe find standard agent and find agent by request type have side effects, but we wouldn't expect it if we just have a look at their names. I want to point out, however, that if these functions would, for example, send a HTTP request behind the scenes, or if we would establish some database connection inside of these functions, we would of course introduce a side effect. Just looking at the name of these functions, we shouldn't expect that they do either of that though, but it also always depends on the general context of your application, whether you could expect that they do something like this. For example, if you're building a browser-side web application or a mobile application, you could expect that a find something method or function does indeed send an HTTP request to a backend server. And then we would all of a sudden have a side effect here. But if we don't have that context, if we just have a look at their names, we probably shouldn't expect a side effect to occur here. So therefore this function doesn't have any side effects. It does not change the state of our system or any other state. Now what about this last example, is valid? Here we get two parameters and we validate this, show this message and then return false or true. This function clearly has a side effect, and it is an unexpected one. If a function is named isValid, we expect to get back true or false. And of course we do, but we expect nothing more than that. We don't expect that anything else happens. And here we are also logging this message to the console, which is more than just returning true or false. This is a side effect because it changes our system state, and it's an unexpected one as well. So this is not good code. The better solution here, of course, would be to take this code and create a new function, create user, for example, as we had it before, where we get our email and password. And in this function, we then call if isValid email password. And if that's not the case, we console log that, and otherwise we continue. Now create user is a function where this side effect could be expected, because validation and handling validation errors, that sounds like a task which is involved in the user creation process. But now isValid is a clean function because it does not have any side effects. Indeed, this is now a pure function because for the same email and password values, it will always return the exact same response values. To conclude this module, we'll have a look at another very important aspect, and that would be testing, specifically unit testing. Of course, you should be testing your code. So that means you should be running automated tests, and it would be even better if you would write your code in a test-driven way. This course is not about testing or test-driven development though, but unit testing will indeed help you not just with writing error-free code, but also with writing clean code. Because there's one simple question which you automatically have to answer when you utilize testing. Can you easily test a function? If the answer to this is yes, if you're not having any problems with side effects like data being written to a database, which you typically don't want during testing, and if you don't do 10 different things in one function, which are then therefore difficult to test, then it's great and you probably have clean code. If the answer is no, though, if you find that one function does too many things and you therefore have to write many tests testing different things for one and the same function, or if you have a lot of side effects in there, then you might want to consider splitting up your function so that you have multiple functions which are then easier to test. And that is how unit testing will help you write cleaner code and especially will help you write slim and focused functions. Because it turns out that small functions, which only do one thing and which don't have unexpected side effects, are way easier to test than big functions. Now, as an example, here's another dummy function, addProduct. It's validating some input, showing an error message, and then creating and storing a product. And therefore, of course, it's very similar to the createUser example you saw earlier in this module. Now, obviously, we can immediately see by now that we have mixed levels of abstraction here, and that the distance between the level of abstraction of the function name and the level of abstraction of certain steps in that function is too big. But even if we wouldn't see that, we would face problems when we try to write tests for this function. Here are two dummy tests as we could write them in JavaScript, for example. And of course, no matter which programming language you use, your tests will look something like this. I got two test cases here, and in the first case, I test whether the overall creation of the product works. In the second case, I'm actually only interested in the ID, and I want to find out if the ID was generated correctly. Because it turns out that my ID should be composed of both the name of the product as well as some random number which is converted to a string. Now, when writing these tests, I can see and feel that something's wrong with my addProduct function. Because for one, we have an unwanted side effect. Not an unexpected one, but an unwanted one during testing. We are writing a product to the database. In addition, if I'm just interested in testing whether the ID was created correctly, I still have to run the entire add product function, including that unwanted side effect, just to then find out whether the ID was generated correctly or not. So therefore, this clearly signals to us that something's wrong with the function. We could test more, for example, if validation fails. For that, we would need to check whether this function completes successfully or not. And all these tests would run on the same function, testing totally different things. So clearly, this is not a great function. We should split it up so that we have multiple functions which are then easier to test. This is how we could refactor this add product function to be cleaner. It's way shorter and it's split up into multiple smaller pieces. I have the validate product data function, which throws an error if we have invalid input, and even that is split up further into the input is valid function and then the reusable is empty and has min value functions here. And the advantage of this is that I now, for example, can write tests which only test the is empty function. So I can only test this small unit now, and I can test parts of my validation, or also the entire validation if I wanted to, without running the entire add product function. I can also test just the generation of an ID if I wanted to, because I did extract an extra function for this. So I could check whether an ID is generated correctly without creating an entire product and storing that product in some database. And that is why unit testing helps you with writing cleaner code. You could derive this code without unit testing as well. But when writing tests and when testing everything, which I don't do in this solution, I just have some examples here, but when testing everything, you will automatically see what should be extracted and what should not be extracted. Because you want to extract as much as possible to write as many tests as possible, as long as they make some sense, of course. Now we don't need to write any unit test for add product. We could write an integration test for this, but we do have all these unit tests which we can write for the small extracted functions we have here. That's why testing matters, not just for avoiding errors and bugs, but also for writing clean code. Now that we know how to name things, how to format our code, and how to write clean functions, which is super important, we're going to have a look at control structures in this course section. Add loops, and most importantly, if statements. Because it turns out that control structures play an important role when it comes to writing clean code. To be precise, you want to avoid code like this. This kind of code is also sometimes called arrow code because it looks like an arrow from left to right, and we have deeply nested control structures here. If statements that contain for loops, which then contain more if statements, which then yet again contain nested if statements. This is super hard to read, super hard to maintain, error prone, and therefore definitely not clean at all. In this course section, we are going to work on this example and learn different techniques and rules which we can apply to turn this into cleaner code. Therefore, specifically in this module, we're going to have a look at how to avoid deeply nested control structures like the one you just saw. We're going to have a look at error handling, try-catch, and how to utilize errors in your application instead of using if statements. And of course, as always, and as you just saw already, we're going to do all of that at a concrete example. You're going to see demos, and I will also give you a chance to practice what you learned. Now, I have one warning about this section. This will be a very practical section. We'll have less slides and more refactoring on the code. This long code, which you see here, will change a lot throughout this section. We'll refactor it a lot, and we'll even refactor our refactoring results. Because that is how you write clean code, and I can really show everything we learned up to this point, including some new concepts you should be aware of, at this concrete example, and I want to take you with me on that journey of improving this code. So if you're not a fan of refactoring, and if you're not a fan of seeing code change a lot, then A, clean code and writing clean code will be difficult for you anyways, and B, this section might not be so great for you. Nonetheless, what I will show you is super important and is how you do actually write clean code. And this section is less about tons of new rules and concepts and more about applying what we already learned combined with some new rules and concepts. So therefore, let's dive in. Now, before we dive into this messy code I showed you and before we will start cleaning it up, let me give you an overview over the various techniques and rules which we have when it comes to cleaning up control structures. Because of course, an important part of using control structures in a clean way is that you avoid deep nesting. To achieve this, we can use factory functions and polymorphism, and we'll of course see what exactly that is and how it helps us. You can also tweak your naming or the way you formulate your if checks a little bit, and for example prefer positive checks over negative checks, because positive checks are typically a bit easier to understand. And you can also utilize errors and not just see them as a problem, but instead use them in a smart way to get rid of certain if checks which you don't need actually. Of course, the composition and polymorphism and the error part here will also be important tools when it comes to achieving the main goal of avoiding deep nesting. Now, these are all concepts we're going to have a look at throughout this course section, but I will actually start with a different concept: guards. When you have deeply nested code like this, it can be overwhelming if you look at this code. Where should you start? Well, you're going to see various ways of slimming this down and making it cleaner throughout this module, but one very efficient tweak, which you can make in a lot of cases, is that you use so-called guards and that you fail fast. Now, what does this mean? Take a look at this simple snippet. We have an if check here, where we check whether an email includes an @ sign, and if that's the case, we do a bunch of work inside of that if statement. And that bunch of work could be multiple lines of code. It could be as much as all the code you have here in the outermost if statement. So all this code here ultimately is in this one if check here. Now, if you have a case like this, you often can use a guard, which means you simply invert the if check. For example, in this case, by checking for the opposite with an exclamation mark, so for the email not including the @ sign. And this is JavaScript, but of course you can do this in any programming language. The exact syntax might just matter. And then you do one important other thing. You just return inside of that if statement. And that means that you now use this if check as a guard. It runs before your main code runs. And if you make it into this if check, so if some condition is not met, in this case if the email does not include a @ sign, then you fail fast. Which means you return, which in the context of a function means that the code thereafter, all the code after the if statement, won't execute. This is what makes this if statement a guard. It guards the rest of the code. If this condition is not met, because we fail fast, we avoid that the other code will run at all. And we had the same behavior on the left side, but there the to be executed code was inside of the if statement, and therefore it was nested inside of it, making it harder to read. A guard is typically way easier to read and to understand. And you can not just use that if you have one if statement which wraps all your other code. You can also use a guard if you have a nested if statement in another if statement. For example, let's say here, has purchases. We could also outsource this and turn this into a guard where we fail fast, so that we then have two consecutive if statements instead of one deeply nested one. And this is a super efficient technique for removing unnecessary nesting. Now let's apply it to our example. Now, how can we add a guard here? Definitely feel free to try this on your own. And for that, of course, you can pause this video and then try restructuring this code such that you are using a guard in there and that you fail fast. And you should be able to get rid of some nesting by doing that. So here's your chance to pause the video. Thereafter, we'll do that together. Of course, before you try solving this, also have a look at the entire code, so all the code in the code file which you find attached, so that you get a feeling for what this program does, which kind of data we're working with, it's a list of transactions, and so on. And if you're not fluent with JavaScript and you're not ready to transform this because you're not sure how to write this in JavaScript, you should still understand the general idea of the code and what it's doing in general. And you can then also, of course, solve this in theory and or by writing down some pseudocode. So definitely give this a try, no matter if you write real code or not. Were you successful? You can easily add a guard by converting this if check, this very first if statement here, to the opposite. What we're doing in this if check is in the end, we're checking whether transactions is a thing, so if it's not null to be precise, and if it is not null, we check if we have at least one element in there. Because transactions seems to be an array. So therefore, what we can do here is we can invert this. And we can check if not transactions, so if this is null, or if transactions length is equal to 0, so if we have no elements, so if we have no transactions at all, if the entire object is null, or if it's an empty array, then we make it into this if check. So now we inverted this condition. Instead of having two conditions, which both have to be met, we now have an either or decision where one condition failing is enough to make it into this if block. And all we have to do in there is then return. And once we added this, we can get rid of this if statement here, which wraps the for loop. So we can also get rid of it down there. Now you see actually here we had an else block, so we did not just return. So actually we can also put the content which was in the else block in there as well and then return. We still need to return to avoid that the rest of the code doesn't run, but if there was extra work which we wanted to do in the else case, we can of course do that before we return. So we log this to the console and then we return. And this is a guard which we added, which already removed one level of nesting in this big chunk of code down there. Now there actually also is a second guard we can extract, which works a bit differently and which is harder to spot. So if you didn't spot that, that's no problem at all. That is why we are also doing this together. But maybe you can see it now if you have a look at the rest of the code. Which other guard could we find in there? A good indicator for a guard or for a guard being used is if you have an if statement with a lot of code inside of it, where you then maybe have an else statement with some error message or anything like this. And we do have this here for this if check, where I check if a given transaction inside of this loop has a status of open. If that's the case, then we do process it depending on the method that was used. We have different functions, fictional functions which are being called. These functions do exist, but they just log something to the console. But if the status is not open, if we don't make it into this if check, we make it into this else block and we log this to the console. So this if check could also be replaced with a guard-like object. We could add a if check here and check if the transaction status is not open. So again, the idea of a guard is that we invert the check. And if it's not open, then in this case I don't want to return because I'm still in a loop which I want to continue going through, but I can use continue. And statements like continue and break exist in most programming languages. In the context of a loop, it means stop the current iteration and continue with the next one. And that's what I want to do if I make it into this guard. I don't want to try processing this as a credit card or PayPal or plan payment or refund. Instead, I just want to continue with the next loop iteration. so that we have a look at the next transaction. Now we also printed an error message, so I will do that first before I continue. And now we can get rid of that else block here. And we now also removed one extra level of nesting here. Now we can have the same logic here for the refund case. So here we can also get rid of this and add our guard instead and get rid of this else statement down there. But of course, now that we have the same code in both these branches for the payment and the refund, we can also take this guard and remove it from these nested branches and instead lift it up to the beginning of this for loop. Now we check for this status right at the beginning of the iteration and continue with the next transaction in line if the status is not open, and continue processing the transaction otherwise. And that again makes that code already a bit more readable because we removed one level of nesting here. Now, of course, with this transaction status guard added here, we should also remove this wrapper if check here in the payment branch, just as I did it in the refund branch. And for the moment, that's it for guards here. Of course, this is not the final code and we'll clean it up way more than that, but this is a start. Now we at least use guards to make this code a bit more readable. So now we added guards. If we leave aside the fact that we have a bunch of if statements here, we should see another problem with this code though. And that is the mixture of levels of abstraction. What we learned about functions still applies. This is inside of a function after all. And when it comes to simplifying control structures and managing deeply nested control structures, splitting up functions and extracting control structures into functions is another important building block. Now this starts with the checks here. We can run the checks here in line, but we could also outsource this into a separate function, which then also would allow us to use positive wording. For example, here we are interested in whether we have transactions or not. So we could grab this code, cut it, and add a new function below this process transactions function. And we could name this function isEmpty. And then simply return the result of this check, of course ensure though that we get transactions as a value. So isEmpty will return true if we have no transactions object or if we have no elements in transactions. And I named this isEmpty and not has no elements because of this prefer positive checks rule here. It simply is easier to read if we use a positive statement than a negative one. So if I name this isEmpty, I can simply check here in process transactions if isEmpty transactions. Passing transactions to isEmpty. And this is super easy to read. If isEmpty transactions, then we do this. Now, of course, speaking of mixed levels of abstraction, we do have more violations of that rule. For example, also this console log statement. It's not directly related to the if statement and to simplifying the if statements, but of course we might also want to extract that. So we can grab this console log statement and add another function here. Show error message could be the function name, where we get the message as a parameter and where we then simply output the message like this. And then we could call show error message here and forward this message which we want to show to again have an equal level of abstraction here. Now, of course, extracting these two functions didn't remove the if statement. It also didn't shorten this code here, but it makes it a bit more readable. And overall, that is our end goal still. Nonetheless, when we talk about extracting functions, it's not just about extracting Boolean checks and deriving Booleans or showing messages. It's also about extracting entire control structures from our code. And that's therefore what we're going to do next. So now in process transactions, we have our guard, we have our for loop. I want to keep the for loop here because after all the function is named process transactions. So it makes a lot of sense that we go through all the transactions there and process them. But what we do inside of the for loop could very well be outsourced. Not discard, I want to keep it here because I call continue, I execute the continue statement here, and therefore I want to keep it close to the for loop code itself. But what about this code down there, where we check whether it's a payment or a refund, and then we process the different methods, or if it's an invalid transaction type. This code could definitely be cut and outsourced into a separate function. That would already make process transactions way slimmer. So therefore we can add a new function here and maybe name it process transaction. So not transactions, that's the function name we have up here for all the transactions, but inside of the loop, process transaction for a single transaction. Hence here we get the transaction as a parameter. And I know that the word transaction is everywhere here. You can go for a different name if that's confusing to you, but I want to use a name that best describes what's in that variable or parameter, and it is a transaction after all, so I will stick to this name. And then inside of process transaction, I will paste in my code here. Since I use transaction as a parameter name, this code all still works because I'm still checking transaction here, transaction type, method, and so on. So this code still works, but now here in the for loop, after our guard, I can simply call process transaction for the given transaction. And that makes process transactions way easier to read and way cleaner. It's still not as clean as I would want it, but it is way cleaner for sure. We could now, by the way, even take our guard here and extract it from process transactions, even though I said I didn't want to do that, but we can do it because we're going to rewrite it, and move that into process transaction at the start and replace continue with return. We can do this here because process transaction will execute for every transaction. And we want to continue with the next loop iteration if the transaction status is not open. But since I have this as a guard in front of my checks down there, if we return here, this code down there won't execute. So since this is then therefore the only function which is being called inside of that loop, it's the same as continuing, but it's now even cleaner. Because now we removed more code from process transactions, and you could argue that this is now on the same level of abstraction. Maybe you would argue that this for loop is more lower level than calling some other functions, and we could therefore also extract this code into another function, but I personally have problems finding a good name for this function. We would have to name it something like loop through transactions, and that's essentially the same as describing what's happening in there, and it's also pretty much the same as process transactions. So finding a new distinctive name for this loop operation is pretty hard for me, and I personally would say that this code is very readable and clean. So I am fine with keeping this for loop here in process transactions for now, and then just outsourcing all the work to process transaction. The work for the individual transactions and the work for checking whether this transaction should be processed in the first place or not. So at this point, process transactions already is pretty readable and slim. Process transaction, on the other hand, is not. We got our guard here, but then thereafter we got all this code. And the question is, how can we simplify that? It will turn out that we can do multiple things, but a first step could still be that we extract even more functions. And therefore, of course, as always throughout this section, feel free to pause the video and try this on your own. Try to extract more functions which would make sense to you. After a short break, which you can use to pause the video, we're going to extract more logic together. So, did you find functions you could extract? I think one kind of function we could extract is a function that deals only with payments and a function that deals only with refunds. That's something we could do. So we could add a new function here, which we name process payments, for example, or process payment, because we're actually working on a single transaction, where we then get our payment transaction as an argument. And we could grab this code here, because we still need to check which method was used, and put that into process payment. And because I used payment transaction as a name here, I'm going to replace the transaction variable here with payment transaction. Now we get this code down there, and therefore here we can call process payment and forward the transaction. And obviously we can do the same here for our other transaction type, for the refunds. We can cut this and add a new function, process refund. Here we get our refund transaction as a parameter, and in the function body we have these if checks, and we work on the refund transaction. So let's make sure that naming is right. Now we got process refund, and hence we can call this here process refund forward the transaction. Now here we're logging an error, though with the addition that we also have a transaction here. So we don't just have a message, but we also print the transaction, which was the problem. And here we also have an error, though here it's just a message. Now we already have a show error message function, and we could now just tweak this a little bit so that it does not just print a message, but also information about the, let's say, item, which was responsible for the error. And we could therefore simply print the message and then check if item is set, so if it's not null, and then also console log the item, for example, so that we console log both the message and the item. And that's the JavaScript way of doing it. This check is important because item might not be set. For example, when we call show error message here, then we pass no second argument, and therefore item would be undefined, and I don't want to console log undefined. That's why I first of all check whether we have an item, and if we do, then we console log it. And with this tweaked show error message function, we can use it here to show an error message, and we can also use it down there to show an error message. And now with that, process transaction is way more readable. But we can certainly extract more. What about these checks? They are on a different level of abstraction than the rest of this function, because we just call other functions here, and then we have these low-level checks. Now, I personally think that's not this bad, because this is quite straightforward to read. Nonetheless, you could make the argument that you want to be extremely clean and that you therefore want to outsource this as well. Though keep in mind that you also can reach a point where you're splitting too much, and this here is definitely on the edge. Nonetheless, we could add a new function here where we check if the transaction is open, and we get the transaction as a parameter, and then we return in the body the result of checking if transaction status is equal to open. And that should be transaction, of course. This was a mistake I made before as well. This should be transaction, not transactions, because it's inside of process transaction. Now here we can check if a transaction is open, or to be precise, if it's not open, by adding this exclamation mark. As a side note, you might argue that this is not phrasing this in a positive way then, but I would argue that the name of the function itself is phrased positively. It's is open, not is not open. And then we just add an exclamation mark, which is quite easy to pick up. Now we could definitely rename this to is not open and change the check in there to get rid of the exclamation mark here. And if you find that easier to read, you could of course also do that even though it's not phrased in a positive way. Now I will go back to not is open though. Alternatively, you could also name it is closed. The problem with that just is we don't know if the only other status is it being closed. So we can't check for this being closed. If there's also something like void or anything like that, then this check wouldn't succeed. So here I really just want to check for whether it's open and then not continue if it's not open. That's why I'm solving this issue like this. With that, however, we extracted this logic, and of course we can do the same here for the payment and the refund. We can add functions for isPayment, where we get a transaction, and then return this check, and a function for checking if it's a refund. So here we have isRefund, and we get a transaction, and we then simply return the result of this check up there. So return transaction type equals refund. And then we can just call isPayment here and forward the transaction, and isRefund and forward the transaction. And now we got rid of these mixed levels of abstraction, and we now got a pretty readable process transaction function. Nonetheless, we're not done yet. It's definitely way cleaner than it was initially, but what about these two functions, process payment and process refund? These functions actually have code duplication, kind of, inside of them, and they also are still not super clean, you could argue. So what can we do about them?